Good afternoon, everybody. My name is Anand Ranganathan, and it's a pleasure to be talking at the Stanford Innovation Week in this very interesting new format. I'm the Chief AI Officer of a startup called Unscramble. Our main goal at Unscramble is to empower people with the right data and insights that they can use to make the most informed decisions that they can. And we do this through a technique that we're pioneering called conversational analytics. So in this talk, I'm going to present why this is important and also give you a brief hint about what this looks like. So as we can all agree, times are changing. So the last few months have seen a dramatic change in the way people live, play, and especially work. So we now live in a world where it's very common for people to be working remotely from anywhere. There's been a dramatic increase in the use of collaboration platforms at work, technologies like Zoom, Slack, Microsoft Teams. In fact, the CEO of Microsoft, Satya Nadella, has said that they've seen dramatic increases in the pace of digital transformation in the last few months compared to before. So even though people have figured out how to be more productive in remote settings, there still remains one big bottleneck, and that is data. Organizations still find it very difficult to get people, especially business users of different kind, access to the right kinds of data that they need. And data adoption remains stubbornly low and in fact continues to drop. So in fact, according to recent surveys, only 31% of businesses say that they're data driven, and this actually has gone down since a few years back. And one reason it's probably gone down is that as people are working more and more remotely, they have less access to the tools and the people that they might have relied on in their offices to get access to data. But in general, most business users still find it very complex to get access to the right kinds of data. They think it takes too much time to get the data. They depend on people with the right kinds of skills, especially IT specialists or data analysts, to get the data that they need. And there's also lots of tools available that they may not be familiar with. So that's a big problem. Even though over the past few months, work has migrated to collaboration tools like Slack and Microsoft Teams, data is still left behind. And there's a big gap between business users and the data. And in fact, this is a problem not just in enterprises, but even in the general public. And this has become very apparent in the last few years, and especially last few months, where there are lots of reputable and good data sets, open data sets that are available about different kinds of topics. But most people are not able to get access to those data sets and create their own inferences and insights. So if you take an example of the coronavirus, over the last few months, there have been lots of public data sets by the Johns Hopkins University. The New York Times has its own data set. The Wall Street Journal has its leading data set effort. So lots of very good data sets that give very meaningful and deep information about testing and cases and deaths and hospitalizations. But most people don't have good access to this data because they're just not technically equipped to take this data and make their own inferences. So what happens instead? So most people still rely on somebody else to take the data, the raw data, and create charts or dashboards. So most people, and this includes the general public as well as business users and organizations, they get their insights from pre-built dashboards. And this is problematic for different reasons. These pre-built dashboards have very limited or sometimes no drill downs. So it's very difficult to dig deeper into the data and get more understanding. Very often it's very difficult to know what the source of the data was. How did the person making those charts actually take the raw data to produce insights? And most tricky is that these dashboards tend to be actually more like opinions than facts. So when you're creating a dashboard or a chart, it's very easy to cherry pick the right kinds of stats and create mislead the public in some cases to further some agendas. So let me take an example from a few months back. So there was a claim a few months back that the United States was doing an amazing job in controlling the pandemic compared to other countries. And there was a chart that was shown in different media outlets stating that the US is doing great. So in this chart, if you see this chart, it says that the US has a case fatality ratio of just 6% and is doing better than most of the countries that have much higher mortality rates. But this chart is actually kind of misleading. So it uses cherry-picked stats. So there's a few other countries that are being shown in this chart. And also the exact metric that's being shown here, case fatality, is kind of a more deeper and not the most obvious metric. It's definitely not the best metric to decide how well a country is doing in combating the virus. So if you take a better metric like cases per 100,000 people, the US is actually in the worst 10 or 12 among all countries. So this is an example where even though the raw data is available, people can get their insights from these charts, which might have been created in a very misleading fashion. Another example from a few months back. So there was this graphic that was making its rounds around Facebook, Instagram, and WhatsApp and other channels, stating that democratic states were doing a far worse job than Republican states in dealing with the pandemic. So in this chart, it says that they picked about 10 democratic states, New York, New Jersey, Connecticut, and a bunch of others, and said that cases and deaths in those states were so much higher than Republican states like Texas, Florida, Ohio, and a few others. So, and this was shared a large number of times on these media, on different social media outlets. And eventually, I think this came out maybe end of April, and sometime in May or early June, USA Today fact-checked this and said it was false for different reasons. So, first reason was that Maryland actually has a Republican governor, but more interestingly, the actual numbers were wrong. So, Democratic states actually had fewer deaths and cases. Republican states actually had more deaths and cases than this chart was showing, and the other problems as well. So it doesn't highlight that there's typically significant underreporting of cases because of poor testing, at least at the beginning of the pandemic. It's also conflating correlation with causation. So there are actually better ways of explaining the differences between these states than just politics. So population density and demographics are better explainers than politics. So in fact, after this fact check, Facebook, which before was allowing this graphic to be shared very often, eventually labeled this as false information and put it into this one at least. So this is a couple of examples where even though the raw data is available, most people just don't have the bandwidth or the skills or the tools to be able to get their own insights from the raw data. And while I've shown examples from the coronavirus and in the general public, the same situation occurs within different enterprises, where business users still rely on other people to create the insights for them, and which is both time-consuming and potentially misleading in some cases. So what's the solution? The solution is to have more power to the people. We need to find ways for people to be able to play with the raw data themselves. And our approach that we're using to tackle this problem is called conversational analytics. So conversational analytics is essentially an approach where we allow people to ask questions in natural language, which means in plain English and possibly other languages too, and get responses again in natural language and charts. So this is a very powerful way for people to get access to data without having to know any deep technical skills. In fact, Gartner has predicted that in a few, if I remember by the end of this year, 50% of all analytical queries could be generated or analyzed through natural language interfaces rather than through technical interfaces. There's several interesting challenges as well as opportunities here. So firstly, there's to make this happen, we need to make lots of advances in different kinds of AI technologies. So we need better natural language processing, machine learning, ability to create automated insights from data sets, create the right kinds of charts and natural language to explain what's going on with the data, and personalize all this for any given user. So different AI technologies need to come together in order to make conversational analytics possible. But the big advantage here, the big opportunity here is that such a tool or such a platform can be easily integrated with common collaboration platforms like Slack or Microsoft Teams, which are already conversation based. So instead of just conversing with your colleagues on these interfaces or chat platforms, it'd be great if you can actually converse with your data. And that's what we want to go towards. So we want to go from the old world where business users might say they don't have access to data and it takes days to get answers to even simple questions, to a new world where business users as well as general public can have their own personal data analyst, an AI-powered personal data analyst that can give them the insights whenever they ask for it. So I'm just going to have one slide describing our product at this point. So we will be developing a tool called Cubo Insights, which has a bot called Cubo, which is a user's own personal data analyst, where they can ask questions in natural language about different topics. So here are some examples of questions about sales. So if they can ask questions in English like, why is sales down this month? What's the predicted sales in the next 15 days? Show me the trend for sales by time of day. What's the response for certain kinds of promotions the last month? So we want people to be able to ask questions in plain English and get the relevant data and insights. So I'm actually going to switch over to a demo at this point, and just to give an idea of how we think such a system might look. And this is an example of this is our interface. This is a chat-based interface. It might look similar or familiar to you if you ever use platforms like Slack or Teams, or even things like Facebook Messenger or WhatsApp. So different threads of conversations. I'm going to start by creating a new thread and chat with my personal data analyst called Cubo. So I'm going to call this conversation as, let's say, COVID in the US. So imagine, so in this case, this particular interface has been set up by connecting it to some raw data sets from that are publicly available, so from Johns Hopkins and New York Times especially. So all questions I ask are going to be answered against that raw data. So I can start asking questions in plain English. So I can say things like, say, total deaths. And what happens in the back end is that the system is going to take my question, total deaths, and figure out how best to understand it and get the relevant data or relevant answers from the data sets it has access to. So in this case, it is said that, okay, I'm going to interpret total deaths as this question, what's total deaths? It's given some information about the data set, the range of dates for which we have data for. In this case, from Jan 2020 to September 2020. I'm actually going to zoom in this. And it says there are 187,000 deaths that have happened so far. So the important thing here is that this is a conversation interface, which means you can chat with the data, which means chatting with Cubo, our data bot. So I can then say by state. So in this case, it's now going to give me a few options. It said that should I group by province state, which is what the data set actually has, and give the answers. So now it's going to give me the total deaths by province, by different states. So New York, New Jersey, California, how many deaths have happened in this date range. I can go further and say by month. And now it's going to further enhance the data set and give me more information, both by state and by month. So here, for all the different states, for Alabama, California, and so on, Alaska, and so on, for each month, what the total deaths. I can change the visualization. I can change it from a table to a line chart. So in this case, there are all 50 states, including Puerto Rico, I think, as well. And this chart is a bit crowded, right? So there are lines for every single state. So I'm going to simplify this and say, don't show me for all states, just let's say define and restrict it to a few states. Let's say to Connecticut and New York, and let's say Texas and California. So again, this is plain English. I'm just saying, let me restrict it to these states, and so I can see the graph a bit better. So now let me go back here. This is a table view. Let me make it a line chart again. So now we see the trend over the last few months. So if you all remember, New York and Connecticut had big spikes in April, went down in May, and Texas and California had their own patterns where they had bigger spikes in July and August. So essentially the idea is that with a few queries in plain English, we're able to go from raw data to some interesting insights without having to rely on anybody else to prepare dashboards or charts for us. And so let's not just focus on Connecticut. Let's say I want to find total deaths and total positive cases in Connecticut. So yeah, so there's a number so far. About 4,500 deaths, 55,000 cases, and I can now look at this in greater detail. There's something else that we allow called adding to a board, where let's say I find this is interesting, I can add more information here. I can add more group bys. So now let's say I also want to group by, make this monthly, and see what the results are for each month. So we see the total deaths and total positive cases. So lots of cases and lots of deaths as well. One thing we can see here is possibly that the positivity rate has been going down. So in this initially lots of positive cases compared to total cases, but in general it's been going down, and total deaths and positive cases. Let's also maybe add a new metric and say I also want to add in hospitalizations. So I want to say add in hospitalizations, and then just to compare what's been going on. So again, we can see hospitalizations has been going up, especially from April to May. It's sort of delayed from the actual cases when the cases were identified, and actually went down in June and went back up in July and August. So in this case, just by throwing data, asking questions, and doing some more interactions, we're able to go from the raw data to some interesting analyses. I'm going to go back to the conversation view. So one thing that people have been talking about a lot is the positivity rate. So they ask a question like, what is the positive case rate in the last 6 months? So that's the overall cases all over the US, 7.58%. But now let's say define and show monthly. So it's now going to take this, find the positive cases for each month. So it's been going down. So just like almost 20% early on, but now it's closer to 5%. Let's see how it was in Connecticut. So and in this case, Connecticut, you can actually see that the positive rate has almost zero, which is like doing a pretty good job over here. Let's take a few more examples. So let's say we want to find something like the total positive cases. So going back to the positive for all months for the whole US. So this is the total number of cases, positive cases all over the US, and it was went up dramatically in March and April. Another big spike in July. So maybe you want to understand why July was much more than June. So I can even ask some more interesting why-based questions. So let's say, why is the total positive cases in July 2020 more than June 2020, for instance? So just to dig a bit deeper into the data, and this gives an explanation that the positive cases increased from 863,000 to 1.98 million from June to July, and it gives the key causes. So in this case, the causes are basically which states. So it says that Florida has had the biggest increase, followed by Texas, followed by California, and in fact, it also gives the natural language explanation. So the whole point is that this is conversational. So we want the bot to be able to explain what's going on to the user in a combination of charts as well as natural language. Let me just give a last couple of examples. So let's say top 10 states. So now we want to find which states have been the worst in total deaths. So New York has had the most number of deaths, followed by New Jersey, California, Texas, and so on. But let's say we want to compare, we're going to find the states in different manner. Instead of by total deaths, by say positivity rate. The top 10 states by positivity rate in the last 2 months. Right. So what's been going on recently, right? So in this case, we see Mississippi, Puerto Rico, Arizona have had very high positivity rates in the last couple of months. I think from July to August, and close to 20%. And let's invert this and look at the bottom one. So instead of saying top 10, define and bottom 10. So now at the bottom, we see Samoa, Mariana Islands, Vermont, Maine, Connecticut, New York. They all are less than 1%. Right? So this is just a sampler of what we think the future would be for people to interact with data, not just in enterprise settings, but also maybe in general public. And we think it's a way for people to make relevant decisions and informed decisions in a much more reliable fashion than what's possible today. And without a doubt, actually, data-driven organizations, we believe, will continue to lead their respective industries. And this involves in different things. So we don't want people to wait for data. We want people to be able to interact with the data anywhere. The same thing can happen through voice, through a mobile phone. We want people to be able to slice and dice the data whenever they want, in any different way, and powerful group collaboration with the data, and be able to present the findings and repeat the sort of process. So that is what we believe to be the future of work, as well as the future of data access in both enterprise settings as well as for the general public. I'll stop here, and thanks for your time. I'll be happy to take any questions.